So I'm just going to jump right into it. This is a case study. It's titled the BIM Consulting Lessons from a Power Plant project that is actually ongoing. So the overview of this presentation, I'm going to give you a little bit of background about BIM Consulting as an emerging role. Some of you may just have learned about BIM, but now we're talking about new consulting roles, and also about what that entails in terms of the project during an actual project. Then we're going to jump straight into the lessons learned so far, because again, this is still going on. Because a power plant in many ways is a microcosm of bigger issues that I think should be discussed for our industry. So BIM consulting, from our perspective, is before you actually jump into a project, working with a building owner, meeting with the different stakeholders to try and first educate them about what BIM can do for them. And then from there on, developing different kinds of standards that will help them manage the process, establish expectations from a contractual level so that nobody's surprised about what's coming, and ensure that they get what they want. So this is an example of basically developing an overview, which is language for a project manager who may not be familiar with BIM to understand what's being asked for. The actual requirements, which actually delve into the actual processes that will be taking place, not just during design, but also during construction and handover. And the execution plan, which gives you the final level of resolution, because rules are meant to be broken certain times. And specific projects may have that flexibility to meet the requirements, but do it in a way that makes sense for them. So rules are very important. I'm from Mexico, so driving can be a challenge. But what rules give us is the predictability to actually have behavior that we can consistently expect, and also to control our risk, right? To reduce the dangers that may lay ahead. So in our practice, we push for international open standards, such as OmniClass. OmniClass is reflected in things like COBie, which is used for facilities maintenance, handover, information exchange. And that's what's highlighted here, is basically they have a bunch of different tables that cover different classifications for different things. In red here, for example, spaces deals with rooms, so that if you call something a corridor and someone else just identifies it as a CORR, you know that you're talking about the same thing. And similarly, table 23, which is very important for products. So going back to what Bill said about identifying and making sure that we're talking about a piece of air handling unit in a consistent way, it's basically a code associated with a name or a title. And these things start giving us that predictability. So another part of the standards that we help develop is a data and geometry specification. We don't like LOD for reasons that have been sort of hinted at earlier, but primarily because the BIM forum definition, even as it stands today, doesn't correctly distinguish between geometry or detail and development and the actual information that is held by that object. Again, hinting back to what Bill showed us, where you can have a box, but it can be information rich. If the information is accurate, at the end of the day, that's what the building owner wants. So this is, again, relying on a list of there's many things that are in a building that will be modeled by different model element authors. So number one, we're trying to identify who is going to be the author. And number two, we're also going to identify which assets specifically are of interest for a building owner. So they may not care about the furniture, but they care about emergency lighting. They may care about all the doors, or maybe just fire doors. So having that level of resolution to identify what building people that will be authoring these models need to focus on is really important, so that we can do things like automated checking, and we're going to talk a little bit about what that means too. So from our perspective, standardization gives us the basis for doing innovation and doing things at a bigger scale than we can think of. So if you think about the shipping industry by boat, for example, it was very different before the shipping container was developed. Once it was developed, there was consistency in what the actual boats needed to look like. There was consistency in what the trucks had to do. And today we can ship things all over the world for very small fraction of the cost that it used to take. Much safer for workers and just very, very efficient. So that's what these things are translating into. So BIM consulting, again, during a project is a little bit different, right? So first we try and develop the standards so that, again, there's clarity for any owner that is having new projects come on board. But during a specific project, there is the work that BIM consulting does to ensure that we have an independent third-party review, because even though the designers and contractors are very BIM savvy, the reality is with the project pressures of deadlines, things may not be prioritized adequately, and the building owner may not have the ability to actually sit in those meetings and keep everything on track. So part of what we do then is also do periodic BIM compliance reviews to ensure that things are on track. We point out if the requirements are being met, and if there's anything that needs to be pointed out graphically, we also include that so that the model authors know exactly what they have to fix. Another thing that happens during a project is that we start tracking key performance indicators, because what everyone wants to know is, are we on track or not? And as I mentioned, the BIM compliance reviews are a key part of that, basically noting the compliance as the project progresses to ensure that all the requirements are being met, but more importantly, that the intent is met so that the building owner can get what they want. That includes virtual coordination. And just because we're using BIM tools, BIM authoring tools, doesn't mean that people are necessarily looking at the models and how they come together. So we need to make sure that that's happening. The way we do that is we ask for meeting minutes, coordination review meetings to make sure that the issues are being tracked and that they're being resolved at a point in time. Change orders and RFIs. So during construction, we also track, make sure that any changes that are happening in the field, if they're owner required or if they're due to site conditions, if they can be foreseen or not. From a BIM perspective, that's really important for us to make sure that we learn and use every project as a learning experience to refine how the standards evolve over time and make sure that we're not making the same mistakes over and over again. And then there's harder performance indicators such as the substantial completion date, right? So that is set very early in a project. We want to make sure that we're keeping ahead of that, right? If we can deliver a building before it is expected, you can imagine how much revenue and efficiency that brings to being able to have something come online earlier than expected. So back to that data and geometry specification that I showed earlier, where we're telling, okay, you have this asset and it is tracked, we require certain parts of information to be populated against it, is that this is what we're dealing with when we are doing a review today. Like a building owner gets a submission at, let's say, 65, 95% of construction documents, and they're looking at black and white. So part of what we do during our involvement too is we create and generate custom views that are using the information held within the model to make sense of it for people like facilities, maintenance, and operators who need to understand what it's actually gonna, like what is the supply, what is the return, what is the exhaust in this duct system. And furthermore, it's not much more work to generate something in 3D that is also color-coded. And color is obviously an easier way to review. If you see a mismatch, it'll jump at you and you know that the information is incorrect. So we're not manually doing anything. We're just setting up rules that color code and enhance the review that is possible. So that is the facilities maintenance view. But building owners, particularly in healthcare, they also want to check that their what they call owner project requirements, or OPRs, are being met. And they have the same issue where the traditional process is to look at black and white, to try and make sense of it, and look in flip pages, and whether it's physical or electronic, and try and see, for example, the STC rating is met, or that the risk level is met for a room. Those are all things that if we, in our data and geometry specification, tell designers they have to input, we can easily set up views that can color code that and allow the review to be significantly faster and more accurate, because visually you can verify if, for example, the acoustic rating is met or not. And we did this actually as a proof of concept with an existing building, and found many areas where the STC was mixed and matched and did not meet the requirements. And the reason this is important is because for an owner, once they get the facility handed over to them, they have to fix it. So there's no flexibility of like, we can delay resolving this issue, right? They have to fix it, and it's at their cost, their budget, usually unplanned. So the last thing that we normally do is the data transfer. So this is data collection during construction, and also transfer for FM. A building owner doesn't necessarily care about the nuts and bolts of every single piece that goes into a building, but very much like a car owner, they care about what activities are needed to service that building, to maintain the warranties, and make sure that their building is operable. So that's where, again, our focus from the geometric perspective is not as intense from a building owner's perspective. They care that the information is there and that the information is correct, that they have a shop drawing for it. Oh, and one last thing too is that during construction, we recognize that many times the model element authors in the design teams are not going to go and model every individual stud. But we recognize that that's information that is very important to an owner-operator, because they need to know what's behind the wall in case they need to do a renovation. So we have requirements for construction photography normally in these standards, and we use tools that help us visualize that like for example in this case, that the GPS information is captured. And that's for buried services, or basically any wall or ceiling prior to concealment. That is really, really easy to do these days. As you can see here in this area, the iPad, or on the right side, the lens model, for example, the iPad is what is being used in this project, an iPhone. There's nothing fancy that needed to be purchased. That has GPS if you enable the settings, and it has the ability to also track which direction, among many, many other things. So this is also what our data collection looks like. We again, during the construction process, it's nice to have things like the COVID data drops where you start seeing information, but we also give interfaces to allow that to happen online, so that people can upload a shop drawing, upload model numbers, photographs if needed, operation manuals, and that you can on demand review that information to see if it has been provided, which is shown in green here, or not in red. So that's collecting shop drawings, which we try and maintain in native format. So again, they're searchable digital information that can be used to inform decisions. This slide is showing a little bit more detail what that entails. So during design, again, we have Revit models. So building information modeling, as it is in practice, involves multiple models. Then during construction, some of these models may be augmented with additional detail, like fabrication models that will include things like hangers and joint gaps, for example, so that we can do a better degree of coordination. And what's shown here at the bottom is that we do extraction from those models to extract the data, so that then we can collect some of these documents, right? To us, there's no point in collecting this in Revit. Revit can't handle a PDF, for example. We should use the right tool at the right time, and that is why we use an external viewer and database to do that work. So by handover, you have all your models, civil, if it was generated, and you have all your documents, and it's all integrated. And what that allows us to do then is to move that information into specific database. So a building owner may want to use that for asset management or for space planning or for capital planning. Those may be different tools, legacy tools, and we are able to accommodate that by using this workflow. And the reason that data transfer is so important is because it costs a lot of money. It's usually delayed to begin with. It's not uncommon that buildings are operated before you even have as-builts and operation manuals. And obviously that is a very, very big risk, and it's then manual takeoffs that are done by someone to basically transfer information from the drawings into a CMMS system, so something like Maximo or Archibus, where the information is managed so that you can actually generate something like a work order to have someone maintain a piece of equipment. And as it's shown here by magnitude, that is the biggest draw between construction and operation and handover. And that is a big opportunity for BIM, specifically for new construction. It makes sense to piggyback on that work. So this is just a summary of what the BIM consulting role is. Standards development, which involves holding stakeholder design charrettes, developing the design requirements for both not just design, but also construction. And then during a project, doing again, basically QA, QC type of activities to make sure that things are on track. So now we can jump into the project. So this is a healthcare, we basically worked with them to develop their standards. And it was, as I described, there were construction requirements, design requirements. It's based in North Shore. It's the Lionsgate Hospital Power Plant, $26 million project. And it involves the idea of replacing a facility near here at the bottom where you see the smokestack for that boiler, to allow sort of the newer building to connect with the older building, and also because there are seismic concerns regarding the existing facilities building. So it's just basically the idea that they need to upgrade based on the seismic requirements and based on the future work that's planned for this hospital. So it's originally expected to be commissioned by late fall of next year, and then operational a year after, roughly. This is what it looks like the existing facilities maintenance and operations building, where the plant is housed near the south, and then the boiler stack that you see at the bottom. On the left again is the newer building, which was completed in 2014. On the right side is future work that's going to be planned, and they want to connect it. So that was a good idea for doing this project. However, our scope was limited due to budgetary constraints because the healthcare authority is still trying to build this into as basically a business case so that it can be part of every project. Our scope was limited to data collection and handover for facilities and maintenance. So that involves, again, doing data reviews, doing BIM kickoff meetings, training trades on how to upload the information, and doing data management on a day-to-day. The added value is that since we developed the standards, we're also going to try, and we are actively trying to keep up with ensuring that the other requirements are met, such as virtual coordination, the key performance indicator tracking, and the photography. So some of the lessons that have been learned are that, for example, with existing facilities and with a power plant specifically, you're always going to be tying into existing systems. And originally, the standards were created for more of a hospital type project. So one of the challenges here was that we didn't require that they model existing to the same level, because we just expected, like, okay, you could just link in a CAD file and show what you need to. However, in this case, it is very critical to model some of the existing conditions so that they can be coordinated properly, and so that once you move into construction, you can prefabricate things accurately. So the as-builds that were used to start off were obviously old and were not perfectly accurate. So even though there was some laser scanning done, it was focused on the mechanical rooms. But there's a tunnel connecting those mechanical rooms to this power plant. And that was a pain point once we moved into construction, because the trade is basically having to do rework because it wasn't accurately where they expected. And if they're going to prefabricate a lot of this stuff, they obviously need more precision than was provided originally by the design. So what we're suggesting now is to generate an actual spreadsheet that tracks what information is being used to originate your design, and what are the risks associated with that information, and how you're going to verify to make sure that things are correct. Another lesson is that what doesn't get fixed during design is painfully hard to fix afterwards. So here on the left is basically showing a plan view from the landscape drawings. And you can see that there's two trench drains, one on each side. And on the right side, you see what's basically issued for construction, and it basically doesn't have the trench drain. And that's how it was issued, right? And that's the challenge. Landscape did not use Revit, they used CAD. And coordinating these changes is important, particularly if you want to have a record model or an as-built that reflects the built condition. Similarly, it is not uncommon, even very developed teams, to take shortcuts, and they have to show things on the drawing. So what they'll do is they'll use lines, right? So here on the left side, you see a VFD that was basically just shown in lines, and eventually we flagged it. They modeled it. The way that it came to is as these rectangular boxes that are sitting on the floor horizontally. So normally VFDs sit vertically. So we flag this. Again, this is the current model. They're in construction right now. And this is still an issue. We flagged it very early, but it still hasn't been resolved. Because the asset wasn't actually modeled, they didn't allow space for it, and that's going to result in some redesign now into construction. And that was done again for an electronic trap primer too, which is what's highlighted in green there, another green box. This is what we should be talking about at more of these type of conferences, the shortcuts and their impacts. Like, how are we supposed to do virtual coordination if we haven't modeled accurately? So along the same lines, level of development, again, the way we use it is strictly as a geometry, to define geometry. For the information, we use the data and geometry specification that I showed. And in this case, there's, again, a control panel that is sitting on the floor. And to us, LOD means correct location, orientation, size, and extent. From a very early model snapshot, that's the part on the right where the ceiling speaker and the fire detector or smoke detector was basically sitting on the floor. And again, it looks great on paper, it looks correct, but the model is not reflecting reality. And how are we supposed to generate a record model if those things aren't caught early, right? And again, there's lights above, so that is still coordination that should be happening during design. We shouldn't be moving to construction with things that aren't accurate. This, again, is something that we see not just in this particular project, but in many other projects, duplication of elements, right? The architect will model floors and stairs, and then the structural engineer will model them too. This is, again, early on in the project. The landing elevation doesn't even line up. You can see that there's two stairs essentially in there, and because we flagged it, we were able to resolve it. But again, if this had been a project where we weren't involved, it's very easy that this would have been missed and led to additional coordination issues, because there's a discrepancy, fundamental discrepancy in the models. So there needs to be a way of saying, like, which one are we going to trust when we start building? And there needs to be a process parallel to catch these mistakes, have custom views that show the duplication so that we can slice and verify that the extents are being shown correctly if that duplication is inevitable, right? Ideally, we'd like to avoid it. The other lesson is that model clearances, that's part of the requirements, is that they are not only required to model the equipment, but also the clearances. So that's why some of this equipment looks kind of T-shaped. You can think of the main footprint as the inner rectangle. So in this case, these are two heat pumps essentially, and then there's a very congested area on the right with different tanks. And again, it works, right? There's no clash. If you were to run an automated clash detection, there's nothing wrong with it. But from a facility's perspective, you know that those tanks need to be replaced in, say, 15 to 30 years. And someone needs to be able to access them and remove them and replace them. That is not going to be possible if you don't have room, right? You're going to have to shut things down. It's going to be a giant pain. And these things happen on all kinds of projects, right? So what we suggested is, again, those are clearances. Clearances can overlap. That will give you enough room. Further on the back, there's electrical panels too that also need clearance, at least 3 feet. That's kind of the rule of thumb. Anything that needs access, at least provide 3 feet in front of it. So those clearances weren't modeled in 3D, right? So we had to basically know that and point that out. So this has been resolved, again, because the clearances can overlap, the heat pump can move to the left. We can provide more room and access so that things are accessible, right? So this is another order of thinking. It's not just about the design, but it's thinking about how is this going to work in real life and how everything is going to be operated afterwards. Virtual coordination, as we've talked about, is a big issue. There's an industry trend which is to run clash reports, again, run your structure against your ducts. And we find that, well, that can be useful at the later stages of design to kind of get to the nitty-gritty of the final design issues initially. And throughout a design, it's also very valuable to just color code the different systems and look at them, right? The reason we color code is so that things will jump out at us. So we're using color as our ally. And then there's also the idea of clash hierarchy, right? So if you have a steam pipe running, that's going to take precedence over the duct, for example. So having these types of discussions and early on in the project is critical to making sure that you have a clash-free design within reason and less issues during construction, right? Because the problem right now is that design is running into construction and the contractors having to design things. That is not efficient. That is not how we're going to move forward in this industry. Another lesson is what I hinted earlier, is that just because we're using BIM authoring tools such as Revit doesn't mean that people are looking at the models, right? So just doing a virtual walkthrough is many times more valuable than doing an actual automated clash detection. So even within one model, electrical usually, there's going to be conflicts because they're just turning things on or off. They're turning the lights off and showing just the cable tray, and there's always issues. So doing these virtual walkthroughs is critical. The next lesson is, it's kind of a dirty secret in the mechanical world, but schematics and single line drawing diagrams are not connected to the model, right? There's no automation there. So a lot of times what designers end up doing is using CAD basically and then linking it in. So that is a software limitation, and the problem is that then there can be a discrepancy in the number of assets and the types of assets between the schematic and the actual model. So when we're collecting data, that becomes critical, because if there's something in there that is not modeled, we can't collect data against it. The other lesson is that we need to have more formal meetings. So again, we can issue BIM compliance reports that are, 10 pages. We can try and summarize them, include executive summaries that are half a page, but we can't guarantee that people are reading them and that there's actionable items. So what we have to do is, again, have more in face-to-face meetings, and it's just harder to fall asleep and easier than reading 90-page BIM standard too. The consolidated mechanical and electrical and plumbing models make sense. So again, this is not always a possibility, but in this case, we were lucky that the mechanical person was also the electrical person, and that they agreed to use one model. And that is just because, again, the way that particularly Revit uses systems and allows for power and the information to flow, it's it makes sense if you have one model, because otherwise you're going through a link, and that will require additional duplication and a disconnect between the data. So as a building owner too, it's going to be better to receive this model. You can just work off one model to update and maintain the facility as it changes, rather than multiple models. The other lesson now starts getting into more of the people. It's important to have champions in a project, and project teams change. So we found this over time. Many people leave, and you have to basically start from scratch. Another important lesson is that designers will agree to BIM standards in hopes that no one checks. So an independent third-party review is really valuable. Another lesson is that involving the trades and contractors early will pay off. In this case, for example, had they been involved early on, they would have noticed that the way that the pipes were supported would have design implications, and that would have saved a lot of time in having to go back and forth and redesign that part. This just says that we need to share more of our failures too. These types of conferences can be very valuable, and sometimes they're just giving us each other pats on the back for the successes, but we need to talk about the things that aren't working so that we can address them and grow from there. So what we see as the next frontier is just what's been hinted earlier too, is the people, the change management that needs to happen, the human element, understanding the things that we're talking about, like prefabrication, right? It means that design has to be settled, which means that the schedule changes, right? But we need to allow time for that to happen, and then we can get the full benefits. And as Rafael pointed out, we need to be aspirational, right? So our standards are aspirational. They try and push the industry, but reality is obviously going to take some time. We need more practice in projects. And from our perspective, that's always a challenge for us, is we're trying to think of ways to make things fun rather than a chore. So here, this is like those stairs that you might have seen where there's a piano, and once you have it as a piano, more people use the stairs than the electric escalators. So that's kind of hacking the mind, right, for good purposes. And the other final thought that I'm going to leave you with is that low-tech can be high-tech. So this is a now rather old study from 2011, but what it found out through a case study of different projects is that those projects that only had a screen with the virtual coordination going on were less effective than those that had the virtual coordination screen, but also a whiteboard, so that people could work out in a more fluid and in a way that everyone could participate. So low-tech can be high-tech, and that's something to keep in mind. It's not about the technology as much as the process. Thank you.